Hi students, I hope you're all doing well. I'm glad that you all responded to my quiz and uploaded the screenshots. Okay, I'm happy to see your replies and I hope you will be doing the same for all the videos continuously. Okay children, so last class we saw about operating system memory management. So today we are going to see the operating systems lesson part 4. So in this class, we are going to see the another function of an operating system, which is the another function of an operating system. We call it as resource management. Before getting into this resource management, you must know what is memory management. Okay, tell me now, what is a memory? A memory is a space where you can store a large number of data, right? So that the memory is alerted to each and every process to do their job. Now you understood what is memory management? Memory allocation is nothing but it assigning a space to a process is called memory allocation. Now you understood what we saw last class? Okay, now let us get into the topic Introduction to Resource Management. And in this session, we are going to cover Introduction to Resource Management. The next topic is Resource Allocation. And the last topic is RAG and Resource Deallocation. What is RAG? Resource Allocation Graph. We are going to see that in this session later. Now, the first topic is for us in this session, resource management. You know what is memory management? The same way here, a resource is going to be allocated to a process. A resource is anything that is needed to execute a task or a project. So what is resource here? A resource is nothing but a CPU or input output device, a main memory or any application software which you are going to perform. So here if I want to just open a folder, if I'm opening a folder, what it says, you are just clicking on some folder and that folder is displaying to you on the screen, right? So these tasks, who is the responsible for these tasks? Operating system is responsible for opening the folder and displaying it to you on the screen. These all the tasks, all the informations, whatever the task I'm performing in the computer, everything is managed by the operating system. According to the jobs, the resources will be allotted. By whom? By the operating system. We'll see with the example in forthcoming slides. Now you see, a resource is anything that is needed to execute a task or project. It keeps a track of processes that have hardware and software requirements. Yes, whomever is entering inside the computer first, they need to do either input or output. Either they will be handling the hardware devices to type some or to work on some software needs. So that is why I mentioned here software requirements. Okay, example, I told you what are all, we call it as resources. It is given here CPU, input output device, main memory or any software. Okay, now you know basically what is resource management and what it does. We'll see exact definition for resource management now. Resource management is the process of pre-planning. So what it says, you're pre-planning, scheduling and allocating your resources to maximize efficiency. Here, why did I mention maximize efficiency? Yes, if one system or if one resource is needed by two process, if one resource is needed by two process, which means two job, how the system will give only one plate is there, and that plate I have to share it to two-person. How can I do that? It is not possible, right? So I have to give either one person one plate and another person I have to make him to wait so that to receive the plate. Okay, so once the person one is done with the process, I can give the plate to another person. So likewise, this resource management is dealing with pre-planning. So if so many members comes inside, he will have some plan to allocate the resource according to priority. So those priority, everything comes under the category scheduling. Okay, and according to the priority, the system or the resources will be allotted to the process. That's why we make it as efficient. Maximize efficiency means we make it more efficient. Have you understood? In multi-user or multitasking environments, okay, now whatever we do, that is actually multitasking. I want to type a document, I want to take a printout, and I want to just save some file in my folder. These all tasks will be called as multitasking. Okay, and this multitasking environments, how the resources will be allocated, these all tasks will be stored in same memory, that is called main memory. They are sharing only one main memory, so that the CPU have to just fix its own priority and give it as one by one. The CPU cycles and file storage are to be allocated to each user or job. Not only the job means multitask environment, it will take one folder, one resource, one document, one resource, one printout, one resource, like these. So each one, each process and resource, if it is taking, there won't be any problem. But if it is taking one resource for multiple jobs, then there is a problem. So it must be given equal priority for all these things. So everyone must get a chance to work on. So how does it allocates? We'll see how it is allocating. Here, multiple programs executing concurrently. They share the use of same main memory. They take turns using the CPU and they compete for an opportunity. What do you mean by compete here? Competition. They will just wait. They are just eagerly waiting for the resource to be allocated. How the CPU alerts means allocates the resources differently. The CPU first will give the process a resource. That process will execute its task. Once it finishes the typing the document, it will wait for the printer to take a printout. So meanwhile, the CPU will take the system, means while the process is waiting for some job, what happens here? The resource will be kept idle, but the CPU should take its turn and give chance to everyone. So that task will be done by operating system. He is a manager who acts as a manager and manages all the tasks how and when to be processed. Okay, here I'll read it out. The operating system acts as a playground monitor, making sure that everyone cooperates and gets a chance to play. Okay, and now so here we have two type of approach. This we call it as resource allocation graph approach. So here resource allocation graph, what it says. So first one is resource partitioning. So last class, do you remember in last class we saw the fixed partitions and you will have the partial dynamic partitions. So in fixed partitions, what did you do? You will be fixing equal number of spaces to all the jobs. Here the same you will do. You will fix the resources for all the processes. So at that time what happens? They won't have a fight. For example, process 1, resource 1, process 2, resource 2. So like this you will fix the resources for all the processes. That will be a problem. what happens? What will be the problem? Yes, if the process 1 has the resource 1, once it completes the resource 1, once the process is over, it will request the resource number 2. But the resource number 2 is the resource number 2 belongs to whom? Process number 2. So for these type of recurring problems, we go for pool based approach. This pool based approach will tell you how the resources is allocated, and whenever the resources are free, it will be allocated to some process. So there won't be any clashes. Okay, need not wait. For example, if you go on a, means this is one sample exam, means this is a sample for you. This is called resources and this is your process. When process 1 is holding resource 1, it is requesting the process resource 2. So what happens resource 2? When resource 2 is not allocated by anyone, then this can be allocated to P1. But what is doing here? This is holding R1 and also requesting R2. So this is your input device. So it is typing some document and it is waiting for the printer to take a printout. This is called input output device, waiting input output. So we'll see next example deeper. This is the first approach. In this first approach, the operating system decides beforehand. So that, as I said, you fixed partitions. So it is fixing the resource partitions for you in this approach. In resource allocation graph, two processes we have. First approach is it is fixing the partitions. Okay, and what resources should be allocated to which user program. This is what it is pre-planning. Okay, it divides the resources in the system to many resource partitions, where each partition may include various resources. Now you understood, right? I said you fixed partitions, resource partitions, the same. You will be fixing for each process one resource. Example, here you will have some resource table for disk 1. This is allocated to P2. Printer, this will be, if it is allocated, it might be given to some process. If it is free, then you will have the system free. You can avail it and you can complete your process. Okay, this is how the resource table will be displayed for you. And next approach is for your pool based approach. In this approach, the operating system checks the allocation status in the resource table. Now previously what did we see? In this table it will check for the allocation whether the resources are free or not. Okay, in pool based approach it will see the resource table whether the resources are free or not. Okay, and now if it is free or not, resource table, when a program makes a request for a resource, it will check whether it is available or not. Then if the resource is free, it allocates the resource to the program. This pool based approach will check the availability and it will give the system to the waiting program. Any resource requirement can be fulfilled if the resource is free, right? So whomever is waiting and those who need to complete their task, they need not wait, so that the available system can be given to that particular process. Here there is no priority. It is just allocated according to the availability. Understood, students? So allocated resources are not wasted. So once the system is given to some other process, you need not sit, you need not wait like idle. You can just work on it even if it is allocated. Okay, the waiting time can be given to some other process. Understood? So this is your second process. Okay. Now this is how your process and resources looks inside your computer system. So this R1 is nothing but your resources and this P1 is your process. This is simply we call it as process states. Okay, this P is denoted as process 1, which is job 1, and P2 is your job 2. When P1 is holding the resource R1, look at this graph carefully. Resource 1 belongs to P1. It is catching the resource 1. It is holding it. And P2, while P1, when it is holding R1, it needs the resource R2. For example, P1 is holding the input device and it is waiting for the output device. And now this P2 what it is saying, process 2. This process 2 where R2 resource 2 is held by process 2, but it is waiting for the resource 1. Likewise, the processes will depend on the resources where it is already occupied by some other job. When it goes like this, then there will be a problem called deadlock. So there is no any chance to go further. Deadlock. Okay. So this deadlock should not happen. For that we have some solutions. So process 1, when it is occupied by resource 1, so that the resource must be free, let free, then only it can occupy resource 2. So the same way R2 must be released by P2 so that it can hold R1. Okay, this is a simple example for overall resource allocation. Okay, now how the system will be released. Now you all know how it is allocating, how it is released. So the deallocation of resources by the operating system is a way to give a chance to all the jobs who request the resources for their requirements. It is just giving a chance to all the jobs. Once it is given chances, so they have to complete their processes and release the resources. Once it is released, then that released resources can be given to the waiting processes or new processes. Okay, so once the job is done, the resources are deallocated or removed from the memory and it is allocated to new processes again. You all got it? The resources will be deallocated and it is allocated to new processes again. Okay, this is called resource deallocation. And we are going to see a sample video related to resource allocation graph. Okay, this is resource allocation graph. Let's see an example. There are two rooms. One is occupied by first person. Another one is occupied by second person. Now both are in use. So the third person cannot use the rooms. Once the room 1 is empty, then the person 3 can use the room. Okay. Now he can use the room. So he need not wait. Okay. Now let us see, one resource can have multiple instances. If the resource do not have multiple instances, other process have to wait until the first one to be released. Here, process 1, person 1, process 2, person 2, process 3 have to wait. So let's just relate it to this process and resources. Now see this, process 3 have to wait. Process is holding already R1. Process 3 is already hold, needs resource 1. If he needs resource 1, what he has to do? Look at this chain. What did I say? This chain says deadlock. Process 1, resource 1. Once again, we'll see the last part. Once again, look at this. Process 1 is holding resource 1. Process 2 is holding resource 2. Process 1 needs R2, process 2 needs R1. What happens then? If the person needs R1 and that is needed by another person, then the deadlock occurs. So that what it has to be done? Another resource should be given to process 2. Then there won't be any deadlock here. We'll see. will plan the interaction between process and resources to prevent deadlock. We should plan what to be done here. So either to give the resource to that particular person or this person, you have to think so that the operating system will think about this and it will just provide you the better solution, how the resources should be allocated. You all understood through this video?